Alrighty, happy Loosen Up, Lighten Up Day. So on the notes, since I lead off, this year my goal is to put, a couple years ago when I let off, it was to put a crazy math picture up. This year my goal is to figure out what holiday, quote unquote, today is. And today is Loosen Up, Lighten Up Day. Okay? Shedding worries, embracing the carefree vibe, and letting laughter flow. It's like tossing burdens into the wind and embracing whatever. Okay? All right? Okay. So today we're going to start our brand new unit. We have not updated the backboard yet because that's Monday's project. But we will. This is a quick hitting unit because 4.5 is going to be today. This is all you're getting today is 4.5. We'll do the entire section today. Okay? 4.7 then we'll start on Tuesday, which is inverse trig relationships. And really, we're looking at probably by Thanksgiving, which is, in a week and a day, by Thanksgiving, I think we test on this one already. Okay? So it's a quick hitter. Okay? All right? So today what we're going to be doing is we're going to be graphing 2 more of our 6 sinusoidal functions. Today we're going to hit up tangent and we're going to hit up cosecant. Okay? And then tonight, homework-wise, or sometime before Tuesday, homework-wise, we're going to have you graph cotangent and secant because the first 2 slides then on Tuesday are going to be those showing those graphs, making sure you did those correctly. Okay? Whoa. Things just went dark.
That's really cool.
What? Ruh-roh is right. And we're back! Okay, I'm not going to lie to you. Things just all of a sudden went dark. Okay? All right. So here we go. So let's start with tangent. Tell me what you know about tangent. What do we got? It's what? It's opposite over adjacent. TOA. Yep. Okay. It's y over x. Where is it y over x? Say it loud. It's y over x on the unit circle. Okay, so what else could we say in regards to its y over x on the unit circle? What's another way of defining that slope? Good try, though. Okay. On the unit circle, what's another way of saying tangent is y over x? It's what?
Sine over cosine.
It's sine over cosine, exactly. Tangent is sine over cosine. Okay. Tangent is sine over cosine. All right. So now we can graph it. And the way that we're going to go about graphing it is we're going to look for places where it doesn't exist. Okay? Right? Because we've got a fraction now, over here, I'm going to say, well, tangent of x is undefined when what happens? When cosine is 0, because I can't divide by 0. So when cosine of x is 0. Okay? Where we'll go 2 laps. Okay? So we're going to go 1 lap, first lap around the unit circle positive direction, and then we're going to go first lap negative direction. So we're going to go from negative 2 pi to positive 2 pi. Okay? So where is cosine 0. Pi over 2? And 3 pi over 2? Okay, that's in the positive direction. In the negative direction, it would be negative pi over 2 and negative 3 pi over 2. Okay. I'm going to move my graph down here just a little bit, just because then we've got some more space to talk about things. Okay. All right. So we've got those spots. Love it. Okay. Tangent of x is zero when what?
Sine is 0.
When sine of x is 0. Okay. So where does that happen?
Pi, 2 pi.
Pi, 2 pi. 3 more. Negative pi, negative 2 pi. 1 more. 0. Yep. Okay. Tangent of x is positive 1 when what?
Cosine, or sine and cosine equal each other.
They equal each other, right? So when sine of x equals cosine of x, where does that happen?
Pi over 4, 3 pi over 4.
Does not happen at 3 pi over 4.
Oh,
At what? At 5 pi over 4? That's the positives. What about the negatives? Negative 3 pi over 4. And? Negative 7 pi over 4. Okay. Purple. Tangent of x is negative 1 when
sine, cosine, opposite.
so sine of x equals negative cosine of x. Where does that happen? 3 pi over 4. 7 pi over 4. 2 more. Negative pi over 4. Negative 5 pi over 4. Okay. Any other specialties for tangent? We got 0, we got undefined, we got 1, we got negative 1. Any other specialties? No? Okay. So if I were graphing, which we are going to be graphing here in about 48 seconds, hopefully. If I were graphing, how do I graph? I know I can graph 0, right? That's where it hits the x-axis. I know I can graph 1, that would be 1 unit up. I know negative 1 would be 1 unit down. How do I graph, or where do I graph, or what do I do when tangent is undefined? How do I graph an undefined location on the graph? It's a what? It's close. It's not a line though. It is vertical. Vertical wave? No. Vertical. Say it loud. Vertical asymptotes. Yes. Whoa, tap the brakes. Whoa, tap the brakes. How does a vertical asymptote go on the graph? It's vertical, so it's up and down. And it's dotted or dashed. Okay? Not solid. Okay? Dotted or dashed, not solid. My next question to you is this. Can our function, here's my vertical asymptote, can my function cross a vertical asymptote? No. So as it gets closer and closer to 1, it's either got to go shooting up or shooting down. Right? Okay? So the first thing that we're going to put on our graph is we're going to put on our graph our vertical asymptotes. Okay? So make yourself a nice big coordinate system. We're going to put some vertical asymptotes on here. We've got one at pi over 2. We've got one at 3 pi over 2. We've got one at negative pi over 2. We've got one at negative 3 pi over 2. Then we should probably label those. With me. Okay. Next one we said was zeros. Where was it zeros? I gotta remember my colors even. Hold on, I gotta scroll back up. Pink was zeros. So that's at the whole pi numbers. So out here at negative 2 pi. Here at negative pi. Here at 0. Complete the 0. Here at positive pi. And here at 2 pi. Yes? Okay. Then we said that this was blue. Tangent was 1 at pi over 4. 5 pi over 4. Nope, I put that on the wrong side. Excuse me, pardon me. Excuse me, pardon me. Put it on the wrong side of pi. 5 pi over 4 is there. Negative 3 pi over 4. And negative 7 pi over 4. Then we said that tangent is negative 1 at 3 pi over 4. At 7 pi over 4. At negative pi over 4. And at negative 5 pi over 4. With me? we said it can't cross over, so I'm going to start here in this middle one, and then we'll go from there. Let me extend my page down just a little bit so I can get it. There we go. So it's going to become a wave. And a wave. Kind of missed my blue dot there. And a wave. And a wave. And a wave. And that's the graph of tangent. Questions, comments, concerns, clarifications? None? All right, let's go to the next one. Let's go to cosecant. Okay? Tell me what you know about cosecant. It's what? It's the inverse, not the inverse of sine, it's the reciprocal of sine, right? Okay, all right. Okay, so this is 1 over sine of x. Oops, now I lost the whole thing. 1 over the sine of x. Okay. Anything else? No? Okay. All right. So let's do cosecant, because it's a fraction, is undefined when what? When sine is equal to 0? Okay. Where would sine be 0? Again, we'll go negative 2 pi to 2 pi. So 0, pi, yep. So all the integer pi's, right? 0, 1 pi, 2 pi, negative 2 pi. Yep. Okay. We went zeros for pink was next. Cosecant is 0 when what? You tell me. What would have to be 0 in order for this fraction to be 0? The numerator would have to be 0, right? So cosecant is 0 when 1 equals 0. Can 1 ever be 0? No. So that means it is never 0. With me? Okay. Cosecant is 1 when sine equals 1. When does sine equal 1? Pi over 2. I'll erase. I agree with pi over 2. What's my other one? Negative 3 pi over 2 I like. Yep. Cosecant is negative 1 when what? When sine is negative 1. And where does that happen? Negative pi over 2 and 3 pi over 2. Okay. Any other nice ones for cosecant? Cosecant of x equals 2 when what? When sine is a half. Yep. So that would be at pi over 6 and 5 pi over 6 and negative 11 pi over 6 and negative 7 pi over 6. Agree with those? Cosecant is negative 2 when sine is negative 1/2. So that would be 7 pi over 6, 11 pi over 6, negative pi over 6, negative 5 pi over 6. Have you seen a pattern develop in these 1s and negative 1s, 2s and negative 2s in the last couple? So looking black here and looking blue and purple. You notice anything? They're opposite, right, in terms of SIGNs, in terms of positivity. Was it the same here in, so looking blue and purple here? Was it the same? Positivities flipped? Yep. 0 and undefined? Nope, that didn't work out. Okay? All right, but the positivities on 2 and negative 2 flipped. Same with 1 and negative 1. Okay? Let's graph this bad boy now. Bad boys, bad boys. What you gonna do? What you gonna do when they come for you? Okay, so undefined at the pi's. There. There. Oops. Lost my. There. Scientific measuring going on up here. All right, it's 0 never. Okay, then we said it was positive 1 at pi over 2
Hold on, tap the brakes. Positive 1 at pi over 2. Positive 1 at negative 3 pi over 2. We said then negative 1 at negative pi over 2 and at 3 pi over 2. Oops, that should have been purple. We said 2 at pi over 6 and at 5 pi over 6. We said 2 at negative 11 pi over 6 and 2 at negative 7 pi over 6. We said negative 2 at those 4. Okay? Bunch of parabolas. Yep. And there is your graph of cosecant. Okay. Questions, comments, concerns, clarifications? So by Tuesday, we would like you to graph just the same way that we just did these. You'll have to, don't just give me the graph, okay? Okay, don't just give me the graph. Give me the math behind what points you're plotting, okay? You have examples in your notes from today about what we would expect to see for work shown on these, okay? With me? By Tuesday. Okay. I did not get a chance to correct tests last night, nor did Schmeling, but we'll get them done this weekend. We'll get those back to you on Tuesday also. Okay. That's all I got for you for today. Thanks for playing along.